Tsuchi University, Taiwan, Thammasat University, Thailand, UPDN, Peradeniya, is that correct? Yeah, and SCU, Central South? No, sorry, Sichuan, sorry, yeah, Sichuan University. Oh, CSU, SCU, yes, it's very confusing. Okay, are you ready? Yeah. NTU, your question is? Two short answers. Name two body fluid volumes that cannot be measured by the indicator dilution technique. Name two body fluid volumes that cannot be measured by the indicator dilution technique.
Interstitial fluid and your intracellular fluid.
That's correct, yeah. Okay, two short answers again. In the coagulation cascade, name the clotting factor whose activity is inhibited by 1. Heparin action, 2. Sodium citrate. In the coagulation cascade, name the clotting factor whose activity is inhibited by 1. Heparin action, 2. Sodium citrate.
The first one is thrombin for heparin.
Second one?
And the second one is factor 10.
Factor 10, answer is wrong. Yes?
The first one, heparin inhibits anti-thrombin 3. The heparin inhibits thrombin 3, thrombin.
Okay, second one?
And the second, sodium citrate.
Sorry, answer? Second one. What factor does it inhibit?
I'm sorry, I want to clarify my answer again. And,
Just give the answer for one, for heparin and for citrate.
The citrate is to chelate the calcium. And
Heparin?
Heparin is to increase the activity of anti-thrombin 3.
That's correct, yeah. Okay, your question is, what two lung volumes are used in calculating alveolar ventilation? What two lung volumes are used in calculating alveolar ventilation?
The vital capacity and the dead space.
Answer is wrong.
The tidal volume in the anatomical that space.
That's correct, yeah. Okay, fourth question, two short answers. In the renal venous blood, name the major cation with a concentration less than 50 millimole per liter, and name the major anionic buffer. Let me repeat. In the renal venous blood, name the major cation with a concentration less than 50 millimole per liter, and name also the major anionic buffer.
Potassium and plasma proteins.
Potassium and plasma
And
proteins.
albumin.
Sorry?
Plasma protein, mainly albumin.
Answer is wrong. Yeah.
Potassium and bicarbonate.
That's correct. Okay, the last question in this cycle. For bicarbonate, how is its filtered load in the kidneys calculated? For bicarbonate, how is the filtered load for bicarbonate calculated?
It is calculated by GFR multiplied by the plasma concentration of bicarbonate.
That's correct. Okay, second cycle. Right, you're ready. NTU, your question is, state the two cardiac volumes that is used in a ratio to express an index of myocardial contractility. State the two cardiac volumes that is used in a ratio to express an index of myocardial contractility.
So it's end systolic volume and diastolic volume.
Say that again slowly.
Sorry, your question is, what are the two volumes used, right?
Yeah,
So stroke volume over end systolic volume.
answer is wrong. Okay, yeah,
It's the stroke volume and diastolic volume.
that's correct, yeah. It's the end diastolic volume, yeah. Okay. Okay, your question is, Suchi, if a 400 milliosmol per liter solution mixture of two solutes is found to be isotonic, what is the explanation? If a 400 milliosmol per liter solution containing two solutes is isotonic, what is the explanation?
Because some of the solutes can diffuse through the cell membrane.
Answer is wrong. No answer? Okay, if the solution has 400 milliosmol, it has two solute, and if it is still isotonic, it just means that one of the solute is non-penetrating and has a osmolarity of 300. That's why it's still isotonic. Yeah. Question 3. Okay, your question is, state the effect, if any, of a blood concentration of potassium at 6 millimole per liter on skeletal muscle function. State the effect, if any, of a blood concentration of potassium at 6 millimole per liter on skeletal muscle function.
It makes the skeletal muscle, it makes it harder to stimulate it hyperpolarized.
Say that again.
Make the skeletal muscle hyperpolarized.
Yeah, that's correct, yeah. Sorry, I had a little bit difficulty listening here. Okay, it's hyperkalemia hyperpolarizes the muscle membrane, it's harder to stimulate. Yeah, that's what he said. Yeah, okay. Okay, your question is, name the regulatory hypothalamic hormone that is reduced during the suckling neuroendocrine reflex. Name the regulatory hypothalamic hormone that is reduced during the suckling neuroendocrine reflex.
Prolactin inhibitory hormone.
Say that again.
Prolactin, PIH.
PIH. Okay. Yeah, the judges accept your answer. Yeah. So, prolactin inhibitory hormone, and one of that is dopamine. Yeah, that's correct. Okay, your question, fifth question is cycle. Okay, two short answers. What physical principle is used together with the concept of renal clearance to determine renal plasma flow? That's the first part. Second one, what is the indicator used in this measurement? I repeat, which physical principle is used together with the concept of renal clearance to determine renal plasma flow? Second one, what is the indicator used in this measurement?
The indicator is PAH, and the principle is just renal clearance.
Answer is wrong. Yes.
It's a fixed principle, and the parameter used is urine concentration of PAH and plasma concentration of PAH, and the
That's fine. Yeah. Okay, that's correct. Yeah. Yeah, this is a fixed principle and renal clearance concept and PAH, para-aminobutyric acid. Yeah. Okay, we go on to the. Is it the last cycle? Yeah, last cycle. Have I asked everything? Yeah, that's right. Yeah, I have. Yeah. Okay, you ready? So your question is, how does the neurotoxin tetrodotoxin specifically cause respiratory paralysis? How does the neurotoxin tetrodotoxin specifically cause respiratory paralysis?
Is it paralysis of the diaphragm?
We want you to tell us how does it do it. This is in a question way.
It blocks the because diaphragm is a skeletal muscle, so it paralyzes it.
How?
By inhibiting the neurotransmitter for contraction.
Answer is wrong.
The tetrodotoxin inhibits sodium channel and cause muscle paralysis.
What kind of channels?
Wanted gated channel.
That's correct, yeah. So it actually reduces action potential generation and transmission, yeah. Okay, your second question. In uncontrolled diabetes mellitus, state the reason for the effect on the general excitability of the brain. In uncontrolled diabetes mellitus, state the reason for the effect on the general excitability of the brain.
Sorry, can you?
Yeah, say it one more time. In uncontrolled diabetes mellitus, state the reason for the effect on the general excitability of the brain. Brain.
In DM patient,
Louder.
in DM patient, neuron degeneration cause the neurotransmitter that cannot deorganize the cause the brain to break down?
Okay, I think the answer is wrong. Open it up. Yes.
Ketoacidosis will decrease the excitability of the brain.
Sorry? Ketoacidosis?
Will decrease the excitability of the brain.
That's correct, yeah. So it's ketoacidosis, and when the pH decreases, the membrane excitability decreases, yeah, okay. Third question, during overhydration, okay, overhydration, how many times lower than plasma osmolarity is the most dilute human urine? During overhydration, how many times lower than plasma osmolarity is the most dilute urine?
How many times, right?
Yes.
Maybe 2 times.
2 times is wrong. Yes?
6 times?
6 times is correct. Yeah. Can you tell us why you say 6? Why you say 6?
The lowest osmolarity of the urine that can be produced is about 50 milliosmoles per
Right.
liter. The plasma osmolarity is about 300.
Yeah. 300 divided by 50, yeah. Okay, that's correct. Yeah. Thank you. Okay, second, last question here. In potassium deficiency, name the membrane transporter at the epithelial cells of the renal collecting ducts that is involved in the active reabsorption of potassium. State also the location of the transporter. Okay. Let me see. In potassium deficiency, name the membrane transporter at the epithelial cells of the renal collecting ducts that is involved in the active reabsorption of potassium. And the second one, state the location of the transporter.
Hydrogen potassium ATPase.
Sorry?
Hydrogen potassium ATPase.
Location?
Principal cells.
The principal is the whole thing, the location.
Collecting ducts.
Sorry?
Collecting ducts.
Say it again?
Collecting ducts.
No, collecting duct is the whole thing. That's part of, which part of the principal cell?
Luminal membrane.
Slowly?
Luminal membrane.
Luminal membrane is correct, yes. It's the sodium potassium ATPase which actually reabsorbs potassium actively. Okay. So last question in this cycle to Sichuan. Okay, let's have your cooperation. Yeah. Thank you. Yeah. Yeah. Okay, 2 short answers. For the action potential generation at the sinoatrial node, state the ionic basis for 1, the depolarization, and 2, the repolarization phases. For action potential generation at the sinoatrial node, state the ionic basis for the depolarization, and 2, the repolarization phases.
The depolarization is because the inward current of the calcium. The repolarization is because the potassium. Outward potassium.
That's correct. Yeah. Okay, thank you teams for participating. We'll look at the scores. So is there a tie? There's a tie, okay. Okay, there is a tie, so I will ask the organizer to show me the master sheet and I'll announce the winning team. is the organizers here. Sorry, I actually have a copy of the master sheet, okay? So we have a tie between Sichuan University and University of Peradeniya. Okay, based on the written average scores, don't you want to know? Based on the written scores average for Sichuan and University of Peradeniya, the winner of this group goes to Sichuan.